Hello, everyone. My name is Oz Parchment from the University of Cambridge. Welcome to this session. We have two speakers today, a couple of speakers pulled out. So we'll have a little bit more time for questions and for the session. I'd like to introduce Dr. Marco Rossi from MathWork, who will be talking to us today about overcoming HPC barriers with MATLAB.
All right. Thank you so much. Thank you for being here. Thank you for the kind welcome. And yeah, it's my pleasure to be here in Gabeka and to give this talk about the way me and my team, there is also John, my colleagues here in the room, are supporting researchers throughout the Southern Africa territory. But first of all, let me introduce how we do work with the HPC Center and how do we help the university to scale their computation. And I would like to start with the Cornell University Lab of Ornithology and the way they are leveraging their in-house HPC while detecting and classify a lot of animal sounds actually coming from the oceans, the forest, and many other places. And they use MATLAB, the parallel computing toolbox, and also their parallel server, which is running on a 64 workers cluster to actually speed up their computation. And as you can see in the results here in the bottom, reducing years of development and also reducing the simulation times from weeks to hours. Next, a little bit about my background in what I used to call the innovation cycles, which is, let's say, the interconnection among education, research, and industry. I share a kind of common path of many of you in this room. Now, I started as a student at the University of La Sapienza in Roma, where I did study aerospace engineering. And then I moved to Germany, where I was doing my PhD, basically studying finite element method simulations of polymer gels. And then now I work at MathWorks, where I have this role supporting a research group in EMEA. In the countries that I highlight here in the orange color, these are the countries that I support at MathWorks. So I'm visiting university throughout Southern Africa, but also Turkey and Central East Europe, and I help them with their research projects. And yeah, I have used MATLAB from my first year in the university all the way up to this morning. Yeah, but I will focus in this talk about, let's say, my actual career path and the way I do support a lot of students, research groups in advancing their research with MATLAB and Simulink. So in this photo, you see some of the collaborations that we have spanning from the University of Cape Town to Walter Sisulu University and many others, as you may recognize from the photos in the background. So thanks to my role embracing several research groups in South Africa, I got in touch actually with the manager of the research infrastructure at MathWorks, Shubho Chakrabarti, who in 2020 actually was very highlighted about the talk of Dr. Sitole at the EGI conference 2020. The EGI now stands for the European Grid Infrastructure, which is a long time collaborators of MathWorks. Inspired by that, we realized that with the NIKIs and MathWorks, we have one common goal, that is actually to empower the Southern Africa research collaboration. That's where it comes from, the title of my talk. But what it is MathWorks? So MathWorks is a corporate company with a headquarters in Boston, close to Boston, who develops software like MATLAB, but also Simulink and many other toolboxes that you can use actually to streamline your research. The orange pins that you see on the map are the MathWorks offices all over the world. I'm based in the office in Eindhoven in the Netherlands. In South Africa, we don't have an office, but we have a partner company that is called Optimum Solutions, and John is my colleague with my same role. So we do both support academics in the Southern Africa region. I was mentioning to you about MATLAB, this tool which started back in 1976-77 with Prof. Cliff Moller at Albuquerque University, where MATLAB now stands for the Matrix Laboratory. It is basically a tool for high powerful scripting language. At the time of my PhD in Germany, I was using MATLAB to actually write the finite element codes of my polymer gel simulations from 1D to 3D. And I was using a simple scripting file with an extensions.m. Many of you may be familiar with that. Over the years, MATLAB has been developing a lot, and at today, MATLAB has this kind of interactive notebook, likewise the Jupyter notebook, for example, or you have graphical user interface where you can actually explore your data or explore your images, change the sensibility of your parameters, explore your signals, perform 3D simulations of robotic arms, basically transporting everything you have on a pen and paper in the software to actually speed your computation and your simulations. And this tool, which is used today by hundreds of thousands of users, it is the same that NASA, for example, it is using in the development of the engines, but also of the launching tower and many other aspects of the Artemis 1 missions. We have been collaborating with NASA, but also with Lockheed Martin and other partners actually to the development of the engine, which aim to bring back the man to the moon. Wonderful, great, the American dreams, but what about the Southern Africa context? Well, we do work a lot with the University of Cape Town, where actually there is a dedicated lab, the Africa Robotic Unit, which is making investigations on cheetahs. And actually they use MATLAB and Simulink to investigate the neuromechanics of the cheetah. So they are on the field collecting a lot of data from captive cheetah that are based on a sanctuary very close to Cape Town, but they also go to the national parks to actually collect data with drones of real cheetahs while hunting, with the aim actually of training a deep neural network to investigate the behavior of the cheetah and actually to understand better what is the cost functions that the cheetah is trying to minimize while hunting their prey. So just to tell you that MATLAB is a very heterogeneous tool that can be used in every field of engineering and science, from climate research to autonomous driving, from computer vision to robotics and so on. Actually, students from all over the world have the possibility to access MATLAB, Simulink, and all the toolboxes thanks to the open access license. There are more than 2,400 universities all over the world that have the access to these open infrastructures. In the Southern Africa, we have 27 universities. I put the logos on the right-hand side of some of them. There are not all. And actually there are 25,000 users just in the Southern Africa that every day use MATLAB for their studies as undergrad students all the way to their research or professors in the universities. So a big army of MATLAB users that would benefit a lot actually from the possibility also to scale the computations to clusters and cloud. And as I was mentioning you before, MATLAB is a tool born in academia. Professor Cliff Moller, back to the 1977, he was actually developing this tool called the LIMPAC, which was actually a Fortran code, which have been used to actually help students to solve linear algebra problems during their classrooms in linear algebra. This LIMPAC was then coded in C. MATLAB started with some of the functions that you see in 1981 of the first MATLAB. Some of them are the same functions that you find in MATLAB in 2024. And actually, the guiding principle behind the usage of matrox is still the same. So the tool wants to make the life easier of researchers and students, and also want to enable the access and the use of workflows and tools like parallel computing and HPC. And this will open actually the second part of my talk to give you an idea of how MATLAB scale code from local to clusters. No? There is the possibility to run MATLAB locally on your machine, and also with the MATLAB parallel server, the possibility to run MATLAB remotely in the cloud, in HPC center, and also in big data systems. So, but let's go step by step. Let's start, let's say, with the local usage of MATLAB. I will refer to these slides. Maybe we can start with the left-hand side here. There is a local machine. The MATLAB client actually is the machine where you have MATLAB, the basic MATLAB, and the parallel computing toolbox installed on the machine. And actually, the parallel computing toolbox will enable you to use the full power of your local multi-core processor by using those MATLAB computational engines, which are called workers. You can use the workers interactively, or maybe you can send work for them to run in the background. And the workers actually form the basis of the CPU-based parallel workflows in MATLAB. Now, when several workers are collected all together, you know, in inter-process communication, we call it the parallel pool. And actually, you can initialize the parallel pool either programmatically, you know, with this command parpol, or maybe interactively. We have a lot of graphical user interface that help the users actually to run those kind of parpol. And actually, MATLAB itself will handle all the work, dividing up the task, assigning them to the workers, and actually enabling parallel computing locally on your machine. And actually, with the very, very few changes of your code, this is a simple for loop, you can actually change it in a path for, so a very minimal changes of your code that will enable the MATLAB workers, and then, of course, you start to parallelize your computation locally. But let's move now from your local machine and from your local CPU actually to a cluster. No, of course you can run MATLAB on the cluster the same way that you run it on your local machine, but you will have some constraints. No, you will have maybe to run MATLAB on the single machine, and then you need to log into the cluster and orchestrate all the work by yourself. So we have this MATLAB parallel server that is a tool which helps you to scale your computation across multiple machines on the cluster without never leaving MATLAB. So you can exploit all the power of the cluster. You can access the core across multiple nodes and let MATLAB manages all the setup which is necessary for that. You can prototype locally and then run remotely on the cluster. And also, last but not the least, the MATLAB parallel server interfaces with the HPC infrastructure, or maybe you can use one of the provided scheduler in the MATLAB parallel server. Okay, so in the next slides, I would like to show you how easy actually is to use the MATLAB parallel server by giving you two kind of lines. The first one in blue is the easy of use for the MATLAB users. Why that? Because we observe that research is becoming more and more articulated, and we want to less disrupt as much as possible the workflow of our researchers, which maybe they don't want to learn a new technology, but they just want to use the benefit out of that. And here we come now with the concept of the MATLAB parallel server. But of course, on the other side, there are workflows which are more similar to traditional way of using HPC Center. we have both, actually. You can use MATLAB on both. No, maybe those which is more similar to the traditional HPC center is to run MATLAB on the cluster via batch or interactively using the scheduler. At that point, the researchers need to know MATLAB, but also shell scripting, scheduler, and so on. But we also have a solution for all those kind of researchers that maybe will just to exploit the HPC center, and with the MATLAB parallel server for them, what they need to know is just MATLAB. Then let's say the parallel server will handle all the big work for them. Okay, here I'm sharing some of the benefits that you can have with the MATLAB parallel server, and how actually MATLAB users can use the cluster resources in a very easy way. I don't know, there are some comments, maybe if you use a third-party scheduler like Slurm, there is no need for dedicated hardware or daemon, or user can submit the jobs within MATLAB, and then MATLAB take care of all the other aspects, and so on. At the same way, there is the possibility for MATLAB and for HPC Center to carry on also Jupyter Hub front ends, and we have the possibility now to use a kernel or browser-based MATLAB versions that is available by Jupyter. This scales also to open on demand and let's say all the other front-end interfaces that can be placed on HPC Center. And we have a lot of collaboration actually with a lot of HPC, which partner with MathWorks from all over the world. I will be very, very happy next year to participate at the CHPC conference and have the logo of CHPC there. We are working since a couple of years to make things happen. Yeah, in the next weeks, we are going to meet also with the team of the CHPC to enable actually the possibility for thousands of researchers. We have seen that we have 25,000 users in Southern Africa, actually to make them possible to scale their simulations and their computational effort to the CHPC and run simulations faster. I would like to end maybe with a call to action that is let's collaborate all together to enable the research, the innovation, and also the learning in higher education. The NICIS as the infrastructure, I focus a lot on CHPC, but there is also the other two subgroups, the DIRISA and the Sunren. And with Optimum and MathWorks, we are in touch with thousands of researchers in Southern Africa, and we can help to bridge, to make this connection. I use a Square on purpose because maybe sometimes those collaborations are not smooth, but we can have difficulties related to the infrastructure, to timing, to other projects, to priority. But I really believe that we can all collaborate together actually for the benefits or the end users, which are the university, which are, let's say, the infrastructure where actually the next generation leaders are being prepared for their future participation, let's say, to the solutions of the grand challenges at the same time to the innovation and technology. Okay, with this I'm at the end. Thank you so much for listening, and yeah, if you have any questions, I will be happy to answer you.
So thank you, Marco, for that. Are there any questions?
I would just like to know the rough cost of MATLAB in terms of resource usage, because you see those pretty diagrams on LinkedIn a lot where it's got C is the lowest cost in terms of resources, and then Python is right at the top where it's the most expensive. And I'd just like to know where MATLAB sits between those two extremes.
You mean in terms of cost of computational power or fastness of the...
I'm actually not sure what the diagram shows, but I think in terms of computational resource efficiency, as in how fast you can execute a standard set of code, for example.
Yeah, I will need to check those kind of comparison with other software. We do actually scale up our computational power with tools which enable the collaboration with the HPC center. And you have seen this from this slide here. No? These are some of the HPC centers all over Europe, and there is also one in Canada, where, let's say, all the researchers which are part of a university in these countries where you see the flag here, they can scale up their computation for free to the HPC cluster. In terms of cost and comparisons, I will need to double check that. Of course, this may depend on the particular kind of applications that you would like to have. It's very hard to answer. But yes, as I would say, during my PhD, I have used a lot of software. Some of them have been great for something. Some of them have been great for some other things. There is not the best one, but each one has its own strengths. Then it will depend on the application fields mainly. But yeah, we can chat also offline later. So maybe you can show me the plot you are referring to, and maybe I can get a little bit more context.
All right, thanks.
Thank you.
Thank you. Are there any other questions?
Okay, thank you for the presentation. My question maybe borders on for new users. Are there any training materials available if you want to get into like up to speed with some of the with the cost running code in different applications, and maybe elaborate in terms of how MathWorks works with the universities and researchers in particular on delivering certain outcomes of a project.
Yes, thanks so much for your question. I will answer the first part with the trainings, and maybe I'm gonna actually exit my presentation, as I want to show you those trainings which are available in the platform called MATLAB Academy. You can actually go online to this website, matlabacademy.mathworks.com, and you can access online in the web browser to a platform of trainings. Now, for those university without a license, the on-ramps are for free. So there are 24 trainings which are free for everyone in the world. But as I did show you before, 27 institutions in Southern Africa have this open access license, so you can do all the trainings, which are not only 24. I will just remove them, but I will go down. There is a kind of a filter that will help me to show how many. There are 68 that you can take. And here you can see the topics, no? Circuit simulations, machine learning, all maybe the basic MATLAB, because maybe you don't know MATLAB, you want to start with MATLAB. And actually you can filter here, no? So to go maybe to a particular kind of aspects that you want to learn. Let's consider is machine learning. I go here, I will take the training. It will start directly in the web browser, and you can keep track. Now I'm at 6% because maybe I just started the first module. And the nice thing is that at the end you can also have an official certification. Me and John works a lot with the university, helping them to integrate those training in their curriculums, actually, because the certification they can take is an official certification from the MathWorks training services. That is something that industry purchase from MathWorks and Optimum every year, and the students with this open access license, they can do those trainings during their studies and actually go to industry with those certifications. So there are 64 that they can take. Yeah, part of the other work that we do for university, me and John are always on the field. Every year we have 2 tours where we do visit the major universities in the country. We deliver seminar, workshop. Each can be either very general on the usage of the tool for teaching or research, or very specific. I don't know, last week I was at the University of Johannesburg, and I was delivering a workshop on training a machine learning model to evaluate the remaining useful life of battery systems. So we can do those kind of activities. And then we follow research project from A to Z, from the start to the end. You can consult to us and ask questions whenever you want. Thank you.
Thank you. Are there any other questions? Well, I'll ask one. So you mentioned right at the beginning of your talk, Marco, that about 64 nodes being used for that audio undersea sound project. So it just occurred to me at the time that, like, 10 years ago, 64 nodes was probably 1,000 cores. Today, 64 nodes can be 16,000 cores. How much effort does MATLAB have to apply to the changing hardware requirements over the years? So it changes quite rapidly, hardware, and software, I know, is always very expensive to change. How much effort is that for MathWorks to keep up with the current hardware trends?
Yeah, we have at MathWorks, so we work a little bit like a university. We have a director, the CEO, and then we have, let's say, our departments. So there are departments specialized for each of the discipline, actually, in engineering and science. And then we have a department for parallel computing that is taking care of keeping actually up to date the software with respect to, the evolution of the hardware. I know that some big changes is happening in March 2025. So the new release of MATLAB will be completely new with respect to what we used to see in the past. Will be big revolutions also for the software itself. So the constant development, actually, which is dragged from the users' feedback that people like me and John, while being on the field, collect, like MATLAB is slow for this feature, or this app lacks this button. Then me and John contact the developers, and they, of course, start to prioritize based on other activities that they have the need to have some improvement in the tool. This is why MATLAB has a new release every 6 months. This happened in March and in September. And this is a kind of continuous loop, but it is mainly dragged by the feedback from the field. So any kind of feedback that you may have, please share it with us, because it will help the way MATLAB will look like in the next 6 months or 12 months. And for any specific questions, yes, I will need to drag them back to my colleagues in Boston, where there is the parallel computing team, and I will be happy to tackle that.
Thank you. Thank you.
Thank you.
Marco. So if you'd like to give him a quick round of applause, thank you.
Thank you.